coming to the elements of Earth's magnetism. We have already discussed about Earth's magnetism, the basic part, and this is the second part where we are going to discuss few more things. Where elements of Earth magnetism, there are three elements. One is called declination, one is called angle of dip, and the horizontal component of Earth's magnetism. So we'll see one by one. First, we call the declination or magnetic declination. So this is actually the angle between the magnetic meridian and geographical meridian. So we have already seen in the last part that if you join Earth's poles, geographical poles, with a particular place, then there is an imaginary plane. Suppose this is the plane which is which you get, which is the geographical meridian. This plane you get when you join North and South Pole. So this, if we call as geographical meridian, and suppose there is another plane this plane is magnetic meridian, which is at that particular place where we have calculated the geographical meridian, that particular place we have taken the magnetic meridian, which means we have magnetic meridian means we have taken the north and south pole, magnetic pole of that place, and we have tried to join with an imaginary plane by which we got the magnetic meridian. Magnetic meridian is also the same plane where your north and south of your magnetic needle will come into rest. So suppose if you have, this is your magnetic needle, and this magnetic needle is coming to a rest. Suppose this is north and this is south. So this particular plane is also called as, the joining this to this particular plane is also called as magnetic meridian. Or you can say that a magnetic needle will come to a rest in a magnetic meridian plane. So between these two planes, the angle is what is called the declination or magnetic declination. So the declination or magnetic declination is the angle between the magnetic meridian and the geographical meridian of that particular place. So this is one important element of Earth's magnetism. Now suppose you try to see all the places that have the same declination, and this all places that have same declination, and you try to join them with a line, and you get a particular line joining all the places with the same declination, and that line we call it as isogonic line, right? So since iso means same, so when you have the same declination places joining with a line, we call it as isogonic line. And there are some places where the magnetic meridian and geographical meridian are same. It means the declination is 0, right? So we call, if you join with a line all the places with 0 declination, you will get a line which we call it as agonic line, right? So there are places where the magnetic meridian itself is a geographical meridian. It means that the declination of that place is 0, magnetic declination of that place is 0, and therefore if you take all such places and join with a line, what we get is called agonic lines. Coming to the second element, which we call the horizontal component of Earth's magnetic field. Now suppose we have this magnetic needle coming to a particular rest. So if this is north, if this is south, then from south to north is the direction of the magnetic field, right? So if this is your magnetic field direction, then this is a vector quantity. If you take it as a vector quantity, you can divide, or you can analyze it, divide it with the two components. One is the horizontal component, one is the vertical component. So this I can, if this is the Earth's magnetic field DE direction, then I can say this is the horizontal component BH, this is the vertical component, which is, let's see, BV. Then we can tell that BE is equal to root of BH square plus BV square, right? So using the vector law, we can calculate total. This is the total Earth's magnetic field. This is the horizontal magnetic field. This is the vertical magnetic field of a particular place. And we can also say that BH is PE. Suppose this is the angle theta between the total magnetic field and the horizontal magnetic field. Then we can write BH is BE cos theta, whereas BV is BE sin theta, right? This is a very important thing when we are talking about the horizontal component. But now, just to define this horizontal component, we are very interestingly using this theta. Therefore, this theta becomes very important when we have to define the horizontal component. This angle theta makes the third component, which is called dip or angle of dip. So this theta, angle between the total magnetic field with the horizontal magnetic field, this angle is what is called magnetic dip, and this is calculated by a particular this thing, where suppose we say BV by BH. If you take BV by BH, then we can say that BV is BE sin theta by BE cos theta. So from here we can say this gets cancelled. So tan theta is BV by BH. Therefore theta is tan inverse of BV by BH, right? So this is the angle of dip, which is the inverse tan of the ratio of the two components of the total magnetic field of Earth. So that's how we have done with the three components. We have done with the first one as the declination, the second one horizontal component, and the third one is the dip or magnetic dip of that particular place. As we have seen, this dip is also called the inclination. Suppose certain places have the dip as 0, right? It means that the between the total magnetic field and the horizontal field is 0, right? So such kind of places which have the dip or inclination 0, or where we see that the total magnetic field and horizontal magnetic field is equal to each other and the angle of them is 0, then such points are called neutral points. Neutral points are the point where BE is almost equal to BH, means they are equal and opposite, right? So they are called neutral points. Now coming to this particular case where we see the dip or inclination is 0, and if you take all the lines with the inclination 0, magnetic inclination 0, all such places with magnetic inclination 0, and if you try to connect them, then that line we call it as a clinic line, right? And suppose if places with same inclination and same dip, if they have same inclination and you join them with line, those are called isoclinic line. So suppose this is on earth, if you have, suppose these places are, so you join with this line, so this line is isoclinic line. They may have, so all the points of on this line will have the same inclination or dip. Same way, all the points on aclinic line will have zero inclination. Same way, we also have seen in declination, there are these lines.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.